In 1899, a man alone in a wooden shack in the Colorado mountains built the most powerful electrical instrument on Earth. He sent a signal out. Something came back that terrified him. In 2025, a team of scientists in Santa Barbara built the most powerful quantum instrument on Earth. They sent a signal in. Something came back that no classical computer on the planet can explain. These are not the same story, but they rhyme. And the question underneath both of them is one we still do not know how to answer. Nikola Tesla arrived in Colorado Springs in the spring of 1899. He told his financier he was there to develop a new kind of light bulb. That was not true. What he was actually chasing was something far more audacious. He believed electricity could be transmitted wirelessly across the entire planet, through the Earth itself, with no loss to anyone, anywhere. He chose Colorado Springs because the air was thin, more conductive. He had been promised free power. He built a wooden laboratory on a hill and ringed it with signs that read, "Keep out." Inside, he constructed the largest Tesla coil ever built, 52 feet across, capable of generating nearly 2,000 square feet of electrical streamers. Outside, he drove artificial lightning into the sky. The largest bolt stretched 135 feet. Its thunder was heard 15 miles away. It also knocked out power to all of Colorado Springs. But the lightning was not the discovery that changed him. On July 3, 1899, during a massive electrical storm, Tesla discovered stationary waves inside the Earth itself. He had built instruments sensitive enough to detect electrical changes within a radius of 1,100 miles. What he found was that the waves from distant lightning did not fade. They reflected, they superimposed, they reinforced each other. The Earth, it turned out, could resonate. And then, weeks later, something stranger happened. Alone in his laboratory at night, his instruments picked up signals he could not explain, rhythmic, organized, arriving in patterns he described as counting codes. He wrote about it later, carefully, almost reluctantly. His words were these: "My first observations positively terrified me, as there was present in them something mysterious, not to say supernatural, and I was alone in my laboratory at night." Tesla was not a man given to fear. He had stood inside fields of artificial lightning for sport, but these signals shook him in a way the experiments never had. He left Colorado Springs in January 1900 with unpaid electricity bills, no explanation for what he had found, and no announcement of what he had built. 4 years later, his laboratory was torn down to settle his debts. Decades later, researchers reconstructing his experiment identified the source. The signals were caused by the moon Io passing through Jupiter's magnetic field, a natural cosmic process, broadcasting blindly into space, picked up by a man who had built the right receiver at the right moment. 126 years later, Hartmut Neven, the founder and lead of Google Quantum AI, stood in a very different kind of laboratory. No wooden shack, no copper coils. His instrument is a chip the size of a thumbnail, cooled to temperatures colder than outer space, containing 105 superconducting qubits. Its name is Willow. On October 22, 2025, Google announced a result that stopped the quantum computing world. For the first time in history, a quantum computer had successfully run a verifiable algorithm on hardware, surpassing even the fastest classical supercomputers, 13,000 times faster. The algorithm was called quantum echoes. Here is how it works. A carefully crafted signal is sent into the quantum system. One qubit is perturbed, then the signal's evolution is precisely reversed, and the team listens for what comes back. What comes back is an echo, and that echo is special because it gets amplified by constructive interference, a phenomenon where quantum waves add up and become stronger. To be clear about what happened here, the amplification was by design. It was a feature, not a mystery. The signal came back stronger because quantum mechanics says it should, and yet Willow produced measurable quantum signals that no existing classical supercomputer can feasibly simulate. Certain data points from the experiment would take an estimated 3 or more years each to simulate on Frontier, one of the world's fastest supercomputers. The quantum chip generated them in seconds. The team published in Nature. The science is documented, peer-reviewed, and reproducible. Nothing was unexplained. Nothing was anomalous. And yet, the question the experiment raises, the question underneath the math, is not so easy to dismiss. Tesla built an instrument sensitive enough to hear the planet resonating. He sent energy in, tuned everything precisely, and listened. What came back was organized, rhythmic, and to him, inexplicable. Neven built an instrument sensitive enough to probe quantum chaos. He sent a signal in, perturbed one qubit, reversed the evolution, and listened. What came back was amplified, structured, and beyond the reach of any classical machine to replicate. 2 men, 2 instruments. One in the Rocky Mountains, one in a cryogenic housing in California. 2 experiments built on the same fundamental idea, that if you build something sensitive enough and tune it precisely enough, the universe will tell you something it was not telling anyone else. Tesla's signal turned out to be Io moving through Jupiter's magnetic field, a natural process broadcasting blindly into the cosmos, picked up by a man who happened to build the right receiver at the right moment. What Willow is picking up is quantum decoherence, the behavior of information as it spreads across an entangled system. Also a natural process, also something that was always happening, that no instrument was previously sensitive enough to measure. Both experiments ask the same question in different languages. What is actually here, underneath what we can normally detect? The answers, in both cases, arrived faster than anyone expected, louder than they had any right to be. Tesla called his first observations terrifying. Neven calls his the first real-world application of quantum advantage. One man was alone in a wooden shack at night. One man has a team of 300 in a state-of-the-art facility, but the shape of the moment is the same. A signal goes in, something comes back, and whoever is holding the receiver has to decide what they are actually listening to. That is the question worth sitting with this week. Not whether the machines are haunted, but what it means to build instruments capable of hearing things no one has heard before, and what we will do with what they tell us. If this made you think, subscribe, share it with someone who would appreciate it, and check the description for links to every source referenced in this video. I am Scott Walker, this is AI Curator, and I will see you in the next one.